compute what is the heart rate. Okay, so when you're looking at these little grids, so the ECG is always going to be on little grids. Traditionally, each of these little tiny squares that you'll see, these are always standardized so that each square is equal to 40 milliseconds. Now, an alternate way of putting that, simply because it's going to be cardiac cycle, this is always given in terms of seconds. Heart rate is going to be in terms of beats per minute. So there'll be some conversions. This is in milliseconds, so first step you can do is, instead of writing down 40 milliseconds, you can simply write down 0.04 seconds is the same as 40 milliseconds. So that's one thing that's going to help you out. So the first thing you do is count the number of little tiny squares between the QRS, and usually you just are taking the R peak, so you don't ever look at all these other little parts of the waves, the P's and the T's. So all you're ever doing is looking at the QRS complex, specifically the R. So you count the number of little tiny squares from one R to the next. And it won't matter whether you do these two or if you wanted to do these two. The variance is going to be so small that I'll be able to adjust for any two that you choose. So you just choose two adjacent QRS complexes, count the number of little squares. So for instance, if the number of little squares here is equal to 12, then I simply am going to go 12 squares times each square is 0.04. Then that, once I multiply that out, then that would then give me what is the cardiac cycle in terms of how many beats, what is the beat distance between adjacent ones. So that's simply going to be
0.48.
0.48? Okay, so this person, 0.48 seconds per cycle. So that's going to be the duration of the cycle. Then many times I won't just ask you the cardiac cycle. Instead, I'm going to ask you what is the heart rate of the person. Then the formula that we had is, by doing that, to get the pulse rate or the heart rate is going to be simply 60 divided by the cardiac cycle. As long as the cardiac cycle is given to you in terms of seconds, then that formula will work. If you're using milliseconds, then it's going to be off by 1,000. So in this case, it's going to be 60 divided by 0.48. So the pulse rate is equal to 125 beats per minute. Because this 0.48 is going to substitute down here. Okay? And that's what most people was fouling up on, is they had a hard time saying, oh shoot, the little squares are 40 milliseconds. But when I do the computations of 40 times all this sort of stuff, I get crazy numbers. So you need to use 0.04 seconds. And it's just the speed of the chart recorder that we always use. We have to standardize it, and that's how it's been standardized in the past.
Are they always going to be recording? Or it tells you usually.
Okay, the table, yeah, it will vary, because sometimes if we want to look at kind of small components in here, we'll change the chart speed that we're printing out, and we'll have a multiplied by 10 multiplier. So it could be 4 milliseconds per square.
Oh, okay.
And in which case you have to know what the speed is of the printout that you've been given. So usually On ECG nowadays, we will always print out a short strip and attach it to the form that we give to the physician. On that sheet, it should either be printed out automatically, or you need to write down what is the speed of the strip of information. And that will then dictate what the little squares equal to. But for everything that we do with the standard ECG, it's a stupid number, but they're 40 millisecond squares. Rather than being 25 or 10, it's just the way that mechanically it used to be, and we're now stuck with that viewpoint of the world. Because the old cardiologists were trained that way and they can't convert. Okay?
Thank you.
So this is the one that most people had problems on.
Was there